Okay, so today lesson we are going to talk about the VLAN trunks, EtherChannel bundles. Okay, so I know in the CCNA levels or the basic networking, okay, you learn some of the basic of the VLAN and the trunks, of course, the EtherChannel bundle. Okay, but in here I'm going to show you the advanced. Okay, so we are talking about little bit deep. Okay, okay, let's start. So I'm going to give in it. Okay, to get my whiteboard. Okay, so today mainly we are going to talk about the EtherChannel bundle, the first lesson per hour. Okay, I think the last week we talked about the DTP configuration. So the now we are going to learn the EtherChannel bundle. Okay, so the today topic is EtherChannel bundle. EtherChannel, EtherChannel bundle. Okay, so what do you know about the channel bundle? Okay, when we talk about the EtherChannel, okay, the first thing, this is also known as a link aggregation or port channel. Okay, there's two names we can call. The first one is, it can be a, yeah, I'll write it down. It can be known as, is known as the link aggregation, link aggregation, or we can say it's a port channel. Okay, that's the first point. We can say the port channel. And also the EtherChannel bundle can be multiple physical links into single logical link. That means the EtherChannel bundle means we are going to convert that physical links into single logical link. Okay, so I'll explain more clearly. And also there's a technique to combine multiple physical link to make a single logical link. Okay, so why we do this? EtherChannel can be used for a load balancing and load sharing and fault tolerance. Okay, the main reason which we can use the EtherChannel as, okay, this can be used as for the load balancing, used for the load balancing, load balancing, and also load sharing, load sharing. Also, we can use it for the EtherChannel bundle. Okay, and the next point is the EtherChannel or port channel have a three modes. Okay, so there is a three modes we can define. Okay, there's a three modes in the EtherChannel bundle. Three modes. What are the three modes? I'll write it down in here. The first mode is the LACP. Okay, the LACP. And the second one is the PHGP. And the third one, there's a third one, is a on mode. Okay, we say for that it's on mode. Okay, and also each channel increase the bandwidth. Okay, also increase the availability and the load sharing. Okay, and each channel provide auto configuration, faster convergence, and the cheaper solution. Okay, so these are the features which have in the EtherChannel. So also EtherChannel require some same duplex speed, native VLAN, allowed VLANs, and switch port mode. So EtherChannel required these criterias. Okay, what are the criterias it need? These things. Okay, I'll write it down here. EtherChannel requires some criterias. Okay, it need to be matched. Okay, so EtherChannel must fulfill these criterias. Okay, so that means, so what are the criterias which we need? The first one is it need to be same duplex. Okay, in the link one side need to be a full duplex and another side also need to be a full duplex. Okay, then it will communicate. So need to be same duplex. Okay, and the second one is the speed also it we must be a same. And third one is native. And fourth one, native means the native VLAN. Okay, native VLAN. And allowed VLANs also need to be matched. And the fifth point is the switch port mode. Okay, switch port mode. Okay, just give me a second. Okay, so the switch mode has two modes. Okay, the first one is access. Okay, another one is the trunk. Okay, so these are the criteria that need to be matched. And also EtherChannel not EtherChannel load not equally distributed across all the links bundle in the EtherChannel. Okay, I'll give the examples of the weightage of the EtherChannel. Okay, and also in EtherChannel load balancing is done based on the flows, not based on the packets. Okay, it's based on the flows. Okay, not based on the packets. Okay, and next part is the layer 2 packets are distributed on the source and destination MAC address. By using this source and destination MAC address, the layer 2 packets will be distributed. Okay, also in the layer 3 the packets will be distributed by using the source and destination IP address. Okay, and the maximum of 8 interfaces can be aggregated to form a single logical link. Okay, so I'll explain some other things need to be required. Okay, I'll write it down. Another feature is the load balancing is done based on the flows. Okay, in the Ether channel load balancing is done based on the flows. Okay, not based on the packets. Okay, that's a one criteria you need to remember. And the other things is similar. Layer 2 packets are distributed on the source and destination MAC address. By using that, it will distribute. And also same as the layer 3, the packets will be distributed by using the source and destination IP address. Okay. So, and the next part is,
So excuse me,
yes,
you explained that load balance is done based on the flows.
yes.
By flows, what do you mean actually?
The flows means, it's a network traffic, okay, not based on the one by one packets, okay.
Okay, uh, can you elaborate? Like, is it like you mentioned that robot cells have to be full duplex? So
Yes,
based on how the packets are flowing, is it?
yes.
Yeah.
Okay, clear. It's not the packet by packet, it's not like that, it's not working, okay. It's working with the flow of the traffic, okay. Because in the load balancing, I'll tell the example, okay. The explanations are near, okay. So I'll draw and explain what is happening with the load balancing, because the load balancing happening with the round robin algorithm, okay. So I'll explain more, okay, in the next top criterias, because the, in the next criterias we have to discuss about the load balancing, okay. Okay, the next thing is the ether channel maximum 8 interfaces. That means in the two switches, okay, in the two switches, which we can use 8 physical bundles, okay, like this, okay, up to up to 8 physical links, okay, up to 8 physical links we can combine as a one logical link, okay, we can use as a one logical link. So channel must be made up of minimum 2 ports and maximum 8 interfaces, okay. The minimum is 2, okay, the minimum is 2, but up to 8 you can configure, okay. So each channel or port channel can be configured either manually or dynamically, okay. So that manually means we can use the protocols, and the dynamically means we can use the on mode, okay. So all the things we can configure with the practical session. And the next thing is, EtherChannel port groups can be run from switch to switch or switch to server, okay. So that means switch to switch we can configure EtherChannel bundle. Also, if there is a server which is connected to the switch, okay, also we can bundle, okay, to share the load, okay, to share the load and for the load balancing, okay. Okay, now I'll show you the way it's working, the load balancing, okay. Okay, think if you have a two switches, okay, which is need to be load share, okay. Okay, I'm not feeling well, that's why, okay. Just give me some excuse. So in here, okay, there's a two switch boxes, right? So in these two switch boxes, how we are going to share the load? Okay, to share the load, okay, you need a minimum two links. Okay, minimum two links. Okay, up to 8 links you can share the load. So these two, okay, for the best practice. Okay, for the best practices, best practices, you have to configure the EtherChannel as 248. Okay, so this is the best practices you should follow. Okay, two physical links, or either you can use the 4 physical links or up to 8. Okay, when you use the 3 or 5 or 7, okay, the load will share a different way. Okay, it's not properly divided. Okay, but in here, if you use like this, okay, it will be divided into actually the 50% of the weightage. Okay, so it means 50% for the this link, and the last 50% of this link. Okay, it will share. But if we use the other way, okay, I'll show you that way also. Okay, so if you have a two links, two switches, two links, okay, it will share the load as 50% and 50%. But if we use the three links, okay, it's not recommended in the corporate networks. So the load will share first 35.5% for the first link, and the second 37.5% for this. Okay, and the last 25% is for this. Okay, likewise it will share the load. Okay, so it's not recommended. Okay, that's why it's not recommended. Okay, so you have to follow 248 method. Okay, and the next thing is I want to show you the how the load balancing is work. Okay, because in the F5 big IP, okay, the F5 big IP, the load balancer, okay, how it works. Okay, think this is the F5. Okay, this is the F5. Think there's a two servers is connected to this. Okay, okay, now this is the first this is the server 1. Okay, this is the server 2. Now how it's working, this is the first TCP connection. Okay, and this is the second TCP connection. Now the traffic will come for this specific load balancer. Now it's sending a traffic. First traffic is for the first server, and the second traffic will send it to the second server. Okay, this is the first and this is the second. Now which type of algorithm it's using? It's mainly using the round robin. Okay, you have to remember this, the round robin the algorithm is using. Okay, because the TCP connection which is come to the load balancer, it will share the load as one by one. Okay, the one by one. Okay, not separated, one by one. First traffic will redirect to the server 1, and the second traffic will redirect to the server 2 likewise. Okay, so this one you have to remember. Okay, so this is how the load balancing is working. Okay, if you have any doubts you can ask me now. Okay,
Sir, you mentioned about LACP and PAGP.
yeah,
Will it be taught in next sessions like link aggregation control protocol and
yeah,
port aggregation
yeah,
protocol?
we are talking about those protocols deeply. okay, in this session. I'll explain
Thank you.
everything. Okay. Okay. So how the channel works? Okay. So I'll explain that. I think this is clear, right? Is there any doubts regarding this? No, right? Okay. Next, how the channel works? How the channel works? Okay. The first thing is we have a two protocols. Okay. The first one is the PHGP. Okay. And the second one is the LACP. Okay. So mainly PHGP is a Cisco proprietary protocol. It's work on the Cisco only devices. Okay. So LACP is an open standard IEEE 802.3 AD. Okay, that's the link aggregation for standard for the LACP. So it's working on the open standardly. That means any device, any vendor device can work with the LACP. But the Cisco device is both support for the PHGP, LACP and on mode. Okay, that's the quality of the Cisco devices. So PHGP up to eight physical links, okay, up to 8 physical links can be bundled as one logical link, okay, one logical link. But in the LACP we can goes up to 16, okay, that means 8 for the active, 8 for the active and the other 8 links for the standby. Okay, so this is the features of the LACP. Also, this one called another name as hot standby. Okay, hot standby. So maximum we can up goes up to 16 links in LACP. Okay. Okay. Also, there's a dynamic mode called on. Okay. The dynamic mode is called on. There's a command there. Okay. This is dynamic mode. Okay. So next, we are going to talk about the link aggregation standard. Okay. So the first one is the primary advantage of this using these port channels is a reduction in topology changes when the member link line protocol goes up or down. Okay. So in the traditional model, a link status change may trigger in a layer 2 CP tree calculation or a layer 3 route calculation. Okay. So a member link failure in a either channel does not impact those processes as long as one active member still remains up. Okay. So if there's a one active link is state up, okay, then other two is down, okay, it's not effect for the entire process. Okay, in the entire workload, the traffic, the 100% traffic will flow through this link. Okay, but there's also a disadvantage because when we have a 3 links, it will divide it up to 3 weightages. Okay, but in here now the 100% workload is flowing through this funding. Okay, but the thing is still the link is up and the traffic is flowing. Okay, and the switch can successfully form an ether channel by statically setting them to an on state or by using a dynamic link aggregation protocol. So then we can detect connectivity between the devices. So most network engineers prefer to use the dynamic method as it provides a way to ensure to end-to-end connectivity between the devices. Okay. So that's why mainly we are using this link aggregation standard. Okay. Not the protocol, I'm saying the link aggregation standard. Okay. So next we have to talk about the protocols. Okay. So let's discuss that. The first protocol is we are going to talk about the PAGP. Okay. The PAGP. Okay, what's the mean by PAGP is port aggregation protocol. Okay, so mainly PAGP stand for port aggregation protocol and it's a Cisco proprietary protocol. Okay, it's only work on the Cisco devices. So PAGP automatically convert individual ports into a single logical link. Okay, so if we configure, we can see. So there are two modes for the port aggregation protocol. Okay, actually there are two modes. The first mode is the auto. Okay, and the second mode is the desirable. Okay, so I know in the each channel, okay, you have configured this previously. Okay, but do you know about the meaning of this auto and desirable? Do you know the what are the meaning of this? So in the auto means in the PHP mode, the interface does not initiate a need channel to be established and does not transmit PHP packet out of it. Okay. If an PHP packet is received from the remote switch, this interface responds and then establish a PHP agency. Okay. That means the auto mode. Okay. The auto side is not forwarding any of the PHP packets. Okay. But in the desirable is the mode which the interface is tries to establish an either channel and transmit PHP packets. Okay, so the desirable is transmitting. Okay, transmitting the PHP packets. Okay, and it's so when we configure the two switches. Okay, two switch boxes with the PHP. Okay, the one side always be an auto. Okay, and other side always be an desirable. Okay, why? Because the desirable is the mode which is forwarding the PHP packets. Okay, it's transmitting and the auto will get the packets and update this interface. Okay, but the thing is when we use the auto mode, the interface responds and then establish a PHP adjacency. Okay, if both devices are PHP auto, a PHP adjacency does not form. Okay, so you cannot configure in the PHP the auto and auto mode. Okay, the both side auto will not happen, will not perform any agents adjacency. Okay, that means you have to configure auto and the desirable. Okay. So when we have a desirable, you will see the PHP interfaces can establish the PHP agency only if the remote interface is configured to auto or desirable. Okay. So having a two end of the PHP link in auto mode will not result in a PHP link. So this will not call as a PHP link if you configure auto and the auto. Okay. Because neither side will be negotiate to bring up the PHP the channel. Okay, because there's a no negotiation will happen with this link. So PHP advertise messages with the multicast MAC address of 0100. So I'll show you that. Okay, because in the configuration I will show you what is the MAC address of the multicast. Okay, because I want to show you that because it's a practical thing. Okay, I'll show you that. And the next thing is you can have up to 8 ports in a single PHP channel or logical link. Okay, so in the PHP we can go up to 8 physical links into one logical link. Okay, and all ports in the PHP the channel must have the same speed and duplex setting. Okay, it's must. It's need to be same speed and same duplex. Okay, same speed and same duplex. Okay, so when you have a configuration, we'll do that. Okay, but in here, next we are going to talk about the LACP. Okay, so I'll share you a document. Okay, in the link aggregation and other stuff, VLAN trunks. Okay, in here you can see the details. Okay, so I'll show you that the channel bundle. Okay, in here it will show the auto desirable, what are the features. Okay, the description is there. Okay, the notes are given. Okay, in the Google Drive you can access that. So it's a lifetime access, so you can anytime you can access this lecture sites. Okay, so and the configuration also there. Okay, no need to worry about that. And LACP. Okay, so what is mean by LACP is link aggregation protocol. Okay, so the link aggregation control protocol is the open standard. Okay, which is renamed as the 802.802.3 AD. Okay, this is IEEE standard. So combine with the multiple links into single logical link to increase the bandwidth. So mainly the all the links participating in a single logical link must have the same settings. Okay, so if you have configured, so the both protocols it's apply these rules. Okay, so these rules need to be matched to perform either channel. Okay, so all ports participating must have the same speed and the duplex configuration. Okay, same as the PHP, LACP also have a qualities, same speed, same duplex. Okay, and all ports participating in a single logical link must be in the same operational mode. Okay, that means it need to be a access or it need to be a trunk. Okay, so no port participating in a single logical link can have a span configured. Okay, so I'll explain what is span in another lecture. Okay, what does it mean by span? Okay, so in the LACP, the main advantage is the can have up to 16 ports. Okay, we have a 16 ports. Okay, 18 active and the 18 the standby state. Okay,
Excuse
yes,
me.
yes,
You mentioned that all ports should be in same mode. It should be access so uh, switch mode.
yes, access
So
so trunk mode.
sorry. So normally in access mode, can we can communicate with two switches? Do they have to be trunk all the time, or it
Yeah,
can be access also?
sometimes we are giving access. Sometimes in the in the trunk. Okay, sometimes we are giving access for some specific VLANs, right? To communicate.
Yes, yes,
Okay, that's
yes.
what I mentioned. Okay,
Uh, in
so
the
in
sense, if
that,
two switches have if you are
yes,
connecting two switches,
yeah,
doesn't that the two all ports which are connected interconnected has to be trunk?
yeah, the link is trunk. Okay,
Okay.
but in this trunk, the link can access the VLANs, right?
Yes.
So think there's
So,
only 10, 20, 30. Okay, so I want
okay.
to give the access only 20. So we can configure the VLAN 20 is only for the access. Okay, so likewise, it's going to be same operational mode. Okay, otherwise it's not operating properly. Okay, it's working, but it's not working properly. Okay, the load sharing is can be different. Okay, there are some issues happening. Okay, Okay, clear? Yes, yes? Or do I need to clear?
Yes, sir. Clear, clear.
Okay. Then we are going to talk about, yeah. In the LACP protocol, you need to configure either passive or active mode. Okay. So I'll explain what is the mean by active and passive. So in the PHP, we have a two operational mode, auto and desirable. Okay. So in here, we also have a modes. Okay. Which is called, the first one is the active state, and the second one is the passive, active and passive. Okay, so what is the mean by active and passive? The meaning is same as auto and desirable. Okay, one is forwarding the LACP packets, okay, to negotiate, and other one is going to be a receive that message and perform, establish the LACP. Okay, so who is going to be sent and who is going to be getting? Okay, who is transmitting and receiving? So the active is only tries to establish an Ether channel and transmit LACP packets out of it. Now we know the active is the one who is going to transmit the LACP packet. So this one transmit the LACP packets. Okay, and the passive, okay, and the passive is does not performing or forwarding or transmitting, we can say, okay, anything that mean the passive mode is not transmitting the LACP packets. Okay, because the LACP packet is received from the remote switch, that means the active switch. Okay, and this interface is respond and then establish the LACP adjacency. Okay, so the passive interface always wait to perform the adjacency. Okay, so now the active state will send the LACP packets. Okay, and the passive interface will get the packets, and after that it will perform the adjacency. Okay, so if the both devices are LACP passive and the LACP adjacency does not perform, okay, what does that mean? Because the passive interface is only waiting. Okay, but there, if there is a no active interface, okay, there will be no LACP. Okay, that's why it's applied for the PHP also same as LACP. Okay, the operational mode are same. Okay, clear the active passive states? Okay, so next I'm going to give you a technical part. Okay, so I think all are clear, right? In here it's a simple basic things. So the next part is must for the troubleshooting. Okay, this for the troubleshooting for the EtherChannel. Okay, troubleshooting EtherChannel bundles. Okay, that's what mean this topic. Okay, so the troubleshooting EtherChannel band, that means the troubleshooting is very important, because if we have to remember that the port channel is a logical interface. Okay, you know the physical interface is combined as a one logical interface. So all the member interfaces must have the same characteristics. So if they do not problems, okay, if they do not, the problems will occur. Okay, there will be some issues. Okay, so in the general, when we configure a port channel on a switch, okay, place each member interface in the appropriate switch port type. It can be a layer 2 or layer 3. Okay, so if you are using layer 2 switch or else if you are using layer 3 switch, okay, it is different when you are performing a ether channel. Okay, it's very little bit different. Okay, because if we want to associate the interfaces to a port channel, the all other port channel configuration is done via the port channel interface. Okay, when we perform a ether channel, okay, in the two switches, you can see the physical links will convert into PO1 as PO2 likewise. Okay, I'll show you that. Okay, because that means the port channel. Okay, so the following configurations, okay, I'll show you the one by one within this. Okay, I'll write it down in here. The configuration settings must be matched on the member interface. That means the if we have a two switch boxes, if you are performing a PHCP or LACP, okay, the one member link, okay, so this is called the member link. So the one member link, okay, have to be this character is same. Okay, the first one is the port type. Okay, the port type. The port type means every port in the interface must be consistently configured to be a layer 2 switch port or a layer 3 routed port. Okay, so that means in the layer 2, okay, layer 2 we are calling the interface as switch port, and the layer 3, okay, layer 3 we call as routed port. Okay, I think you know how to configure a layer 2 interface into layer 3 in the MLS. Okay, if not, I'll show you that within the next sessions. Okay, so this need to be a one. Okay, so think it's a layer 2, okay, L2, and this one is L3. Is not performing any ether channel. Okay, if this L2 is need to be in this side also L2. Okay, and the second one is the port mode. Okay, the port mode, I'm talking one by one. Okay, I'll explain one by one. The port mode. Okay, if you have a layer 2 port, channels must be configured as either access port or trunk port. They cannot be mixed. Okay, so in this side it need to be a access or it need to be a trunk. So this will not performing any ether channel. Okay, it's need to be a one side of the port mode. Okay, so it's need to be a match. And the next one is the native VLAN. Okay, the third one is the native VLAN. Okay, what's the mean by native VLAN? If the member interfaces on a layer 2 trunk port channel must be configured with the same native VLAN using the commands using, I'll show you the command, the switch port trunk native VLAN ID. Okay, so that means if you configure this as a trunk, okay, if you configure this as a trunk, okay, so you need to configure this interface is using the same native VLAN. Okay, so think this communication happened with the VLAN 99 for an example. Okay, for an example, so you have to configure these interfaces as switch port trunk. Okay, switch port trunk, the native VLAN, the VLAN ID. Okay, the VLAN ID is 99. So likewise, you have to configure. Okay, so if you want to send the traffic from, so think the VLAN 99 is using voice or in data. Okay, you can use this. Okay, or think there's a wireless connection for the access point. Okay, you can configure. And next thing is the speed. Okay, so speed means all the member interface must be in the same speed. Okay, if these links are performing 1 gigabit per second, all the interface must be in 1 gigabit per second. Okay, and the fifth one is the duplex. Okay, What is the mean by duplex? The duplex must be the same for all member interfaces. Okay, so we have a full, half. Okay, so it's going to be a same. And the next thing is the MTU. Okay, what is the mean by MTU? Maximum transmission units. Okay, so if you have a layer 3 member interface, okay, must have the same MTU configured. The interface cannot be added to the port channel if the MTU does not match the MTU of the other member interfaces. Okay, so that means, so if you have a MTU packet size, okay, so think if you are configuring a bandwidth size as 64,000, okay, so other side also need to be a 64,000. Okay, if it change, it will not performing any EtherChannel bundle. Okay, and also there's a one thing I need to show you. Okay, the thing is, if the switches, okay, if the switches is using the duplex mode, in this side is full, in this side is half. Okay, it's not performing any EtherChannel. Also, you need to know if your switch box is running on VIOS, okay, and this switch is running IOU, okay, the family of the operating systems in switches, okay, it's not performing like that. Okay, if you are using VIOS in this switch, okay, it's going to be a VIOS in this side also. Okay, if you have a IOU, okay, it's not working like that, it's not performing any Ether channel. Okay, clear?
So excuse me.
Yes. Yes, Indika.
Using different network devices, can we configure the ether channels
Yeah,
like
the network
node and
devices means no,
node and
no,
the
no, we are not using Ether channel for the routers. Okay, we can use it for the MLS. Okay, MLS to switch. Okay, MLS to server, switch to server. Likewise,
can we use firewalls?
in the firewalls we have a different design HA. We are not using the Ether channel for that. Mainly the Ether channel is only meant for the switching. For the HA, we can use it for the firewall. High availability. I think these things you know,
Yes,
right?
sir.
Yeah. Clear?
Okay. Clear.
Okay.
Sir, excuse me.
Yes.
You mentioned that they should have the same OS, right?
Yes.
So that in that case, that we cannot run this on different vendors, right?
Different vendors. Uh,
If it is Cisco
yeah.
and
No, no, no,
Huawei.
no, no, no. That means the Cisco to Huawei, we can perform the LACP, okay, but not the
Okay.
PAGP.
Okay, so LACP can be performed on different vendors.
Yes. Yes. In the
So the OS
LACP, we
does
can
not have to
use.
match.
Yeah.
Okay.
The LACP we can perform with the different window. That's just like a Cisco to Huawei, Cisco to Aruba, likewise.
Hmm.
Okay, because the LACP is the one we can perform in the open standardly. Okay, but in there is a on mode. Okay, which we can enable the Ether channel. Okay, but the LACP and PGP have features. Okay, but the features are not available in this on mode. Okay, this is the dynamic one.
So in PAGP, do they have any uh, like hot kind of a hot standby mode? I mean, any redundancy
No, no,
channel
no,
holding LACP?
no. Only the LACP is available that. Okay, up to 16 maximum we can go. Okay, for the links, and the 8 is active and the 8 is passive. That means the standby. Okay. standby. That means the hot standby. Okay. But in the
Okay.
PHP it's not there. Okay. Only up to 8 links we can use the one logical link. Okay.
So even though it is 4, you have only 4 channels stacked together, right? As
Yes.
a single channel.
Yeah. So, and the next. Okay. So let's talk about the load balancing traffic with the EtherChannel bundles. Okay. So it's need to be talk. Okay. Okay. The next one is the load balancing. Okay. The load balancing with the EtherChannel bundles. Okay. So the first point is, okay, EtherChannel provides load balancing only per frame. Okay, not per a bit. Okay, that's why I told you the previous time the flows. Okay, it's only load balancing by using per frame. Okay, so the first point is the load balancing. The load balancing is only for per frame. Okay, not for a bitwise. Okay, and values as calculated by hash algorithm, and that particularly port accepts. Okay, it's using the hash. Okay, hash algorithm.
The same hash algorithm which we are using in like password creation and all, right? That
Yes,
hash, right?
yes. Okay. So a switch decides which member link a frame will traverse the frame. Okay, the switch will decide the link frame. Okay, so but when we configuring active or passive or auto or desirable, okay, there's a one who is sending the first traffic. Okay, the first PAGP or LACP traffic. Okay, and each channel flows uses a particular port cannot be controlled. Okay, so the hash algorithm cannot be configured or changed to load balance. So we cannot configure the hash algorithm. Okay, and the external load balancing can use the MAC addresses and IP addresses. Okay, which we can use by default. Layer 2 packets are distributed on source and destination MAC address, and also by default the layer 3 packets are distributing based on the source IP and the destination IP address. Okay, and the next thing is, so in the port wise, okay, the load balancing is happening in a different way. Okay, because I'll show you that if we have a two ports, okay, if you have a two ports, the load balancing happening in 50% and 50%. Okay, but if you have a three ports, okay, the three ports, the load balancing happening in a different way. Okay, 37.5 into first one, and the second one is also 37.5, and the last one is 25%. Okay, it will share like this. Okay, this is a standard. And if you have a four ports, okay, four ports if you are configured as each channel, so it will share the workload as 25%. Okay, into four ports, it will divide. Okay, so likewise in the 8 ports we have a different type of distribution weightage. Okay, and the next, so the hashing. Okay, the hash option is have a key options. Okay, So I think you know that thing. I think you will receive that, because when you are working on a real device, you will see that if you have a tag called destination IP, DST IP, okay, it's only named as destination IP, and you will see the DST MAC. These are the tags, okay. And if you see the destination port, it will show as destination port, okay, likewise. And if you have a source IP, it show as the SRC IP, okay, like this tag. And if you have a source MAC, it will show as SRC MAC. And if you have a source port, okay, it will show as the SRC port, likewise, okay. So these are the hash option sets, okay. Because in the hash option set, okay, the thing is, if you're using a hash, okay, hash is a binary function, okay. So links should be in the power of 2, okay. For the example 248, that's why we are using 248, okay. To be consistent, a 3-port EtherChannel will not load balance as effectively, okay. Because as a 2 or 4-port EtherChannel, the best force to view the load of each member link is with the command of the show EtherChannel port, okay. If you have a command, you have a command called show EtherChannel port, okay. When you have a configuration, I'll show you that. So show EtherChannel port, okay. When you have a port view, okay, you can see the load. And if you want to utilize that link, okay, is it displayed in the hex under the load and display the relative link utilization, okay. So I know these very different words, it's okay, but you need to learn, okay, because in the hash value it's working as the bits by bits, okay. So okay, so let's first configure the one or two things, okay, then you will understand, okay. Okay, so think we are configuring first as the PHP. Okay, so first you have to get the interface range. Okay, so interface range Ethernet. Okay, 0/0 to 1. Okay, and next, which you can configure the channel group. Okay, you can see we have to give the channel group, but in the packet tracer, when you are configuring in the channel, you will see only up to 1 to 4 or 1 to 6 channels. Okay, you can configure, but in the real device you can go up to 1 to 255 group channels. Okay, the channel group is a different thing. Okay, so when you have a channel group, so you can configure the first channel group as 2. Okay, now these two interfaces are under the channel group 2. Okay, so which we can use up to 255. Okay, so mainly the channel group 2, and next we have to configure the mode. Okay, mode, and you can see there's a few separate modes, right? It's showing the active. Okay, LACP unconditionally, auto, PHP, desirable PHP, on is the enable EtherChannel only. Okay, because it's dynamic mode, and passive. Okay, now we are using the PHP, which I'm going to configure as this side as the auto. Okay, okay, so there's other commands which you can configure. Night silent, this means that start negotiation only after data packet is received. Okay, but we are not configuring that yet. Okay, so enter it. Okay, now we can see the creating a port channel interface. Okay, interface into port channel 2. Okay, next in the IOU2. Okay, in the IOU2 you also have to configure, get the interface range Ethernet. Okay, 0/0 to 1. Okay, and give the channel group, the same group you have to use. Okay, and next if we configure the mode. Okay, first we configure the this side as the auto, and this side is need to be a desirable. Okay, so now the port channel 2 is configured. Okay, so now if you see your spanning tree. Okay, if you see your spanning tree. Okay, you can see there's a no 0/0 and 0/1 because it's not showing in the physically. Okay, because it's now work as the PO2, it's designated listening. Okay, in here I'll also show you that. Okay, now the PO2 is a root learning. Okay, now you know the my IOU1 is my root bridge device, right? If you are configuring each channel, okay, it will skip the block state in the STP. Okay, now you can see there's a no block state, like there's a no alternate block, it's only port channel. Okay, that means it's a logical link. Okay, which is for forwarding the traffic. Okay, from IOU2 to IOU1, because PO2 in here the IOU2 has the root learning. Okay, and PO2 has the designation listing. Okay, if you see again, okay, you can see now it's moving. Okay, that means it's skip the 30 seconds, right? So for the learning and listening, it's getting 30 seconds. So after that you will see it's now convert into designated listening into designated forward. Okay, now this is root learning, right? So now this has to be a root forward. Okay, let's see. Okay, now you can see now it's in root forward. Okay, so this is what happened when you configure the root EtherChannel in the trunk link. So now it's not trunk. If you see the show interface as trunk, okay. Now you can see it's working as the ISL, okay. It's not the IEEE 802.1q. It's not the .1q, okay. And also in here show interface as trunk, okay, because it's automatically in the Cisco devices is automatically configured as the ISL interswitch link. So now this one side has a more desirable and this one also had a more desirable. This desirable is different, okay. In the trunk in desirable is different and also in the EtherChannel desirable is a different, okay. So you can see it's ISL now working, okay. If you want to configure the .1q, you can configure, okay. This is what we have to configure in the last week, but it's now we can see in here, okay. The dynamic trunk, okay, DTP. So next, the configuration of the PHGP is done, okay. So this is the configuration for the PHGP,
So,
okay.
excuse me.
Yes.
So can you show how to flow the traffic within the link?
Okay, I'll show you then. There's a one specific command which you can use to show the load, okay. You're asking to view the load, right, in the member link.
Yes, sir.
Okay, the command is show EtherChannel port, okay. In this one, you can see the device ID and IU2 name, the neighbor details, and the edge time is 25 seconds, okay. And also in this one, okay, the port state of this, okay, you can see the in detail of this when you have this configuration, okay. Now in here, the port channel, the port index, the load is 0x00, okay. It's using the hash value, okay. Now you can see bundle 2, there's some issue with COM, the port channel, wait, okay, is not compatible with Ethernet 00 and will suspended its access, and Ethernet 00 is a trunk, okay. Okay, so look into the interfaces, interface range, Ethernet 0/01, okay, switch port mode trunk, okay. Okay, so it's rejected switch port trunk encapsulation .1K. Okay, so inside also I'm configuring that, okay. For the, that's why I already told you that there's an issue will come, right? So like this error will come in your device, okay. So which you have to configure or access or trunk, okay. So now my Ethernet 00 is in access, my Ethernet 01 is in trunk, okay. It's not compatible, so it will show in the device. Now the all the way there's an error, okay. So you have to fix
Sir,
it. Yes,
sir, excuse me.
yes.
So can you connect two PCs to ensure this?
Two pieces means you want to share the what it called, you need to ping from the other side.
Yes, sir.
Okay, okay, we'll do that. Okay, the thing is, first I want to configure this side, okay. So first go to the interface range, okay, interface range, Ethernet 0/0, okay, -1, switch port trunk encapsulation .1q because it's working in, yeah. Now let's check this site. So interface is trunk. Okay. Now in 802.1q. Okay. Let's see in this site. In this site also we have to configure. Let's see first the trunk interface. So show interfaces trunk. Okay, now in 802.1q. Okay, now it's trunked. Okay. You want me to ping from this side to other side, right? The device is something happened with the error. Okay. Whether I do not know whether it's working or not. So if not working, so we have to configure again. Okay. Because some errors happening. Okay. Let's start this device. Okay. Now with the console, the PC1 and the PC2. Okay, which we can the IP 192.168.10.1. Okay. And next, I want to configure the address /24. And in here, I'm also going to configure the IP 192.168.10.2/24. Okay, let's pick from this site 192.168.10.2. Okay, it's sending the traffic. Okay, clear now?
Clear, sir.
Okay, so that means in this site, okay, in this site in previously there are some facing issues, okay, because in this site when I configure either channel first, okay, it's automatically will become the first, this link is access, okay, and this link is the trunk, okay, because it will automatically trunk by using the ISL, okay, there's an issue. So I make this bundle as 802.1q. Okay, in this site also I configure it as 802.1q. Okay, now that's the one solution for this. Okay, if not performing, it's not correcting each other. Okay, this will be a solution. Okay, clear?
Clear, sir.
Okay, and next we have to perform the LACP. Okay, so I'll show you that.
So excuse me.
Yes.
Can you show us the configuration part again for how to bundle the two connections? Because you said that once you connect the first connection, it will be a access, and the second will be a trunk.
Yeah, first
So, but we
the
have
thing is first we have
so
to trunk the interfaces both side. Okay, then we
So
can configure
both sides have to be trunk.
yeah. First, the
Okay.
first we have to configure
And
the trunk.
both port has to be trunk ports. Is it?
Yeah, because if not, okay,
Basically.
if not, the one link will be perform as ISL interswitch link. The Cisco is using the dynamic trunking protocol to trunk the interface automatically. Okay, then this is for the issue. Okay, so that's why first we have to make this as 802.1q framework, and this one also the same configuration. Then we can move to the either channel configuration. Okay, I'll show you again, then it will clear. Okay, let's configure this. Also, I'll get a computer. It will be easy to understand. Okay, next start the devices. First, let's check the trunk interfaces. Okay, unless there's will be an issue. Okay, so first check show interfaces trunk. Okay, now the both side is trunk by the ISL. Okay, first I'm going to trunk interface range Ethernet 0/0 to 1. Okay, and next switch port mode trunk. So this command will not working. Okay, why? Because the command is always rejecting because already it's dynamic trunked. Okay, so for that we can use the configuration, the switch port trunk encapsulation .1q. Okay, and this side also we have to configure. Okay, interface range Ethernet 0/0 to 1. Okay, switch port trunk encapsulation .1q. Okay, let's check the board side. Okay, show interfaces trunk. Okay, now the two interfaces are trunk as 0.1q. In this side also we can check show interfaces trunk. Okay, you can see the Ethernet 00 and 01 is desirable state and is working with the 801q. And next I'm going to check what happened to my spanning tree. Okay, now the 00 and the 01 is designated forward. Okay, because now this IU1 is my root bridge. Okay, so let's check it here, show spanning tree. Now you can see in my Ethernet 001, 00 is my root forward interface and the 01 is my alternate blocked. Okay, after you configure the port channel, okay, one will be automatically trunked by using the ISL. Okay, that is using dynamic trunking protocol. So first I make the interfaces as trunk state manually. Okay, then I'm going to configure the channel configuration. Okay, so I want to get the range command, and next I'm going to make this channel the channel group. Okay, the channel group, I can use anything, right? 1 to 255, so I'm going to use the channel group 50. Okay, and next you have to make the mode. Okay, so in here I'm using the LACP now. Okay, for the LACP we can use the auto and, or not auto, active and passive. Okay, sorry, the active and passive. So I'm going to, first time I'm using the active. Okay, let's see what happened to the port channel. Okay, the port channel is not configured. Okay, why? Because the range command terminated because it failed on Ethernet 00. Okay, so what is happened to the Ethernet 00 is designated forward. So let's check the show interface is trunk. Okay, it's in same mode, it's using same bandwidth speed. Okay, okay, let's try out again. Interface range Ethernet 0/0 to 1. Okay, and next use the command the channel group. Let's stick with the 10. Okay, or else if you use the 4, channel group 4 mode active. Yes, it can work with the under the 6. Okay, so, and next in this site also we have to configure, because it's showing suspended 01 is suspended. Why? The LACP is not enabled on the remote port. Okay, so where is my remote port? In this side, this interface. Okay, it's not enabled the LACP yet. Okay, so first we have to configure that. Okay, go to the interface range Ethernet 0/0 to 1, and next I'm going to create the channel group. Okay, channel group is 4. Okay, the mode is I'm using this side, I'm using active, in this side I'm using passive. Okay, then the remote port will be up. Okay, okay, let's see what happened to that. Okay, wait until it's negotiate. Okay, so I'm going to capture one interface. Okay, one physical interface. Now you can see it's showing the LACP right in here. Okay, also you can see it's showing the MAC address of this. Okay, and also the if we inspect this, okay, if we inspect this, okay, one of the packet, okay, it's showing the frame, it's showing the Ethernet, and it's showing the 802.1q virtual LAN. Okay, and it's showing the slow protocols. Okay, and the slow protocols, the slow protocol subtype is LACP 0x01. So this is the hash. Okay, which I want to show you. Okay, so actually What is mean by slow? There will be a speed, right? Okay, what's the mean by slow protocol in LACP? Do you have any idea? Okay, I'll explain. Okay, so you can see in 802.1 queue, okay, you will see the priority, okay, and other stuff. The type is the slow protocol, okay. So in the link aggregation, you can see the LACP version is using 0x01 because the slow protocols is a category of the Ethernet protocol, okay. It's defined mainly in a link aggregation control protocol which used as IEEE 802.3 AD, okay. So also you can see the MAC address device, okay, and the priority value, other stuff, okay. And if you go down in here, okay, you can see the aggregation, and also you can see the details of this. The partner key, the group is for check the frame. Okay. So you can see the details of the channel, okay. Detail wise 0x4, okay, this is the operational key. Also it can show in when you capture the link. Okay, now you can see the index ID, the load 00, the port is this one, and the EC state is active. Okay, now the two ports are in now active state, and you can see the times value of the each channel. So also in you can see the logical port, slot port is 16. The number of ports are assigned in 2. Okay, hot standby port is null because there is a no hot standby port, and the port state is port channel, and the protocol is LACP, and port security is also disabled. Okay, so some things are very advanced. Okay, so this is the way you are configuring the channel in the LACP. Okay, is it clear? The LACP. Do you have any doubts regarding this?
So excuse me,
Yes.
is there any hashing value or key?
In here, the 00, that's what I'm talking about. When you capture that link, okay, there's a hash value. Okay, so to check that, okay, you have a unique command, the show is the channel port. Okay, so channel port. Okay, this is the port number, and you can see the load is 0x00. The operational key is 0x Okay, this is the key. So it's based on your port channel number. Okay, if your number is P04, it will change in here. So configure what if happen if we change the port channel. Okay. Okay, is it clear now? Do you have any doubts regarding this? And also I want to talk about the LACP. Have also two different protocols. Okay, the first one is the slow protocol. I show you that in this protocol is slow protocol. Okay, and also there is a fastest protocol. Okay, what is the mean by this? The fastest and slow. What is the meaning of this? The slow means it's our hello time of 10 seconds. Okay, and the dead time is up to 90 seconds. Okay, that's why it's show as slow protocol. Okay, the dead time is 90. So overall each every time the 10 seconds up to 10 seconds it's sending again and again the packets, so which have a 90 second of dead time. So mainly if we have 90 minus 10 is the full time is 80 seconds. Okay, and the fastest protocol, okay, the fastest means it's need of 1 second of fellow time. Okay, and 3 seconds of dead time. Okay, this is what is called the fast. Okay, there are the two protocols. Now it's now this whatever we configure in here. Okay, it's a slow. Okay, when you
So excuse me,
yes,
what are the advantages of these ether channels? Can we increase capacity for bandwidth?
you're asking me that if we can increase the capacity, that means the bandwidth of the link.
Yes, sir.
Okay, it's now we are using a Ethernet, right? The link is Ethernet. So Ethernet means 10 megabit per second. Okay, so if you can use gigabit Ethernet, okay, you can up to 100 megabit per second. Okay, that means two links which is work as one, that means 200. Okay, but the load will share up to 50% to 50%. Okay, so this is not work as actually the 200 megabit per second because it's dividing. Okay, 8 to 15 into 15. Okay, clear? It's up to the link. Okay, okay,
So
sir.
why are you using this?
Which mean
What are the advantages of ether channels?
the advantages?
Yes, sir.
The advantages is okay. The main thing is okay. If you configure the two links within the same different switches, okay. So when we talk about the STP, okay, we cannot use the second link. Why? Because automatically the STP will block one of the link, right? So to skip that, so because the block state is now skipping, okay, now it's not there is a physical link, it's work as a logical. Okay, it's work as PO. Okay, so that's why after we configured, okay, after you configure, when you have a the channel, okay, so if you check the spanning tree, you can see there's no physical link, so there's no block interface, only there is a logical link as a designated forward. Okay, and IOU2 Okay, I'll show you IOU2. In the IOU2, you have only the route forward. Okay, because there's a no this alternate block. Okay, so that means okay, you can use both links. Okay, and also for the load sharing, load balancing, we can use for the ether channel. Okay, and increase the bandwidth. Okay, those are the advantages. Is it clear?
Now it's clear, sir.
Okay, so if you are using a multi-layer switch or a layer 2 switch, okay, the same thing, okay, to share the load and to the load balance the traffic. Okay, that's why we are using this ETH channel method. Okay, it's a very effective and there's a no cost. Okay, to configure this. Okay, clear?
Clear, sir. Clear.
Okay, so now the final one we have to configure is the on method. Okay, the dynamic. Okay, there's a no features. Okay, because if you check the show ETH channel, okay, ETH channel, okay, you can see the protocol is LACP. Okay, and up to 2 ports are working and max port is 4. Okay, so in here we can see the details, but in the dynamic we cannot see because it's only up the state of the ETH channel. Okay, so it's like a dynamically on. Okay, so I'll show you how to configure that. Okay, so if you want to check the connectivity between these two, I can show you that. And PC1, PC2. Okay, IP 192.168.10.1. I was in same IP. Okay, 192.168.10.2/24. Okay, so think if these links are not trunk, okay, think this link is not a trunk. Okay, think it's a access. Think it's access. Okay, what happened? Only the default VLAN 1, okay, default VLAN 1 can communicate within these two. Okay, so if there's a few separate VLANs, okay, few separate VLANs, if you want to communicate within these two, okay, you need to make this port channel, that means the logical link, as a trunk interface. Okay, so that's the practical. Okay, so practically we have to configure the on method. So I'll show you only 2 switches, within 2 switches, because okay, Okay, first configure interface range Ethernet. Okay, interface range Ethernet 0/0 to 1. Okay, so first configure channel, the channel group we can use 3. Okay, and the mode is on. Okay, and this side also we have to configure. First get the command. Okay, and configure the EtherChannel channel group 3 mode on. Okay, let's see what happened to the spanning tree. Okay, because it's not performing, it's performing the PO3. Okay, and let's see. Now you can see the designated forward cost is 100, but it's divided into 56. Okay, and next if you check the command shows spanning tree. Okay, now you can see. Okay, so we have to check the show EtherChannel command. Okay, let's wait. Okay, you can see there's no protocol. Okay, it's empty, but it's connected, right? The ports are 2, the maximum port is 4, but we'll see what happened to the trunk interface. Okay, now it's working as ISL. Okay, it's working. So if you want to send traffic to another side, okay, I'll show you again. Okay. So if it using the ISL or the 802.1 queue, okay, it's working. Okay, now it's using ISL into switch link. Okay, but if it's 802.1 queue, okay, still it's working. Okay, but in the both side it need to be a ISL or a 802.1 queue. Okay, if you configure this side as a 802.1 queue, okay, the EtherChannel is not performing. Okay, so this is a practically what you have done in the EtherChannel. Okay, so if you see the packet, if we capture this, okay, now there's a no link aggregation protocol, right? Okay, it's not showing any LACP or PAGP packet because it's dynamically trunk. Okay, dynamically trunk. Okay, you can see the trunk interfaces, trunk type. Okay, the send ID, the MAC address, everything, but it's not showing in any here. Okay, because it's only up state, getting the state up for the EtherChannel. The features are not valid for this. Okay, It's not performing any LACP or PGP features. Okay. So that's why we are not performing the on mode. Okay. Still we are going for the LACP. Okay. LACP or PHEP. Okay. But most of the time in the industry is using the LACP only. Okay. Because it's compatible with the vendor devices. Okay. It's only using LACP. Okay. I think the configurations are clear, right? Is there any doubts regarding the lesson? Okay, you can see the summary of the details. Okay. Okay, so these are the configuration. Okay, so in here we can set up the max bundle. Okay, LACP max bundle command up to 816 we can use. Okay, but if you want to limit into 4, you can use the LACP max bundle into 4. Okay, so likewise we can configure. So there's some advanced show commands is there. Okay, and this is the port channel load balancing hash option. So this is a Cobolo command, the port channel load balance hash. So you can see to configure this, okay, in the port channel. So destination IP, destination IP address only it can show, okay, and destination MAC, destination mix IP port. I'll show you some of these things, okay. And here you can see the load balance, show EtherChannel load balance. So within the configuration, which I deleted already, but when you configure that, okay, you can see the details of this, okay. IPv4, the source XOR destination, okay, is using TCP UDP and the port number, okay. But in here you can see it's only showing the source destination mixed IP port. It will show, okay. So in here we have to configure the port channel load balance, the hash. The hash value means the one of the hash set, okay, which you can show in here, okay. Let's see, I'll show you one, okay. Okay, now if you can see in here, the command is port channel load balance, okay. So which you can use in default the global configuration mode, the port channel, okay, load balance, okay. You can see the which addresses are available for this device, okay. It's depend on the device version, okay. Now in here it's showing the destination IP, destination MAC, source destination IP, source destination MAC, source IP, source MAC. Okay. So if you want to see the source destination, so let's see if we get one. Okay, destination MAC. So before that we have to check. Okay, you can see the show EtherChannel load balance. Okay, so if we check that, show EtherChannel load balance. Okay, now it's showing the details of the source destination IP. Okay, IPv4 source XOR destination IP address. But in here, okay, I'm going to change that. Okay, the port channel, the load balance, I'm going to change it to source destination IP is there. Okay, I'm using to source destination MAC, SRC, DST to MAC. Okay, so next I'm going to check again. Okay, show the EtherChannel load balance. Okay, okay, now it's showing the source destination MAC. Okay, likewise we can use. Okay, also if we use the debug command. Okay, if you use debug for the configuration, okay, which I'm using LACP. Okay, wait, let's use for the packet the activity, or else you can use all. Okay, okay, you can see the in details of the sessions. Okay, LACP time of the expired, now it's sending packet again. Okay, the packet size is 128. Okay, the TLB values. Okay, everything is coming in here. Okay, so this is like a monitoring. Okay, when whatever we are getting in the Wireshark, all the details will come in here. Okay, so debug commands will helpful to troubleshoot the configurations. Okay, it's not up to the LACP or the channel. Okay, it's also working with the routing protocols. Okay, I'll show you when we have work on the routing. Okay, you can see in here actually. Okay, the LACP time is stop and expired, and it will reactivate again. Now you can see in here the lag partnership up, and the lag is not unchanged. Okay, the lag means link aggregation group, which you configure as a channel group. Okay, so the lag is used for the increase the bandwidth, and also it provide the redundancy, and also it's improve the load balancing. Okay, what is the lag means that. Okay, sorry. Okay, is it clear now? Is anyone any doubt? Hello, can you hear me? Is there any doubts regarding the configurations? Okay, first we have to disable this unless it's working again and again. Okay, just give the no command. Okay, and then it will off. Okay. Okay, so can you tell me, is there any doubts regarding this, or if we can move to the next one? Hello, can you hear me?
Yes, sir.
Yes. Is there any doubts regarding this? Okay, then let's skip to the next session. Okay. Now the LACP is finished. So our next session is, let's see, what is the next session? Okay, the IP routing essentials. Okay, so yes. So before we move to the routing, okay, we have to work on another session with the FHRP. Okay, I want you to know about the FHRP in detail. Okay, after that we can configure the routing protocol. Okay, we have to work on the FHRP. Okay, that means the first order hop redundancy protocol. In that we are going to configure the HSRP, VRRP and GLBP. Okay, there's a three protocols. So mainly in the industry is working with the VRRP because it's working with the vendor devices. Okay, and GLBP also. And next we can move to the routing. Okay, I'll explain in detail in routing, but first we have to finish the FHRP. Okay, that's the lesson pathway. So let's see where's the FHRP. This is the IGRP lesson. Yes, OSPF. The OSPF version 3 for the IP version 6. Okay, the BGP. Okay, BGP is the main concept of in the CCNP encode level. Okay. Okay, I think the 17 to 21 or 22 is the wireless module. Okay, so I have a OneNote for the FHRP, so I'll share it in the group. Okay, so and which what we are configuring in here. Okay, I think you can access this folder, right? You have all the labs, right? Is it available for you?
Yes, sir.
Okay, then configure the basics. What you are configure, the interVLAN router you can configure, STP topology, okay, the dynamic trunking protocol, EtherChannel you can configure, okay. So up to this you can configure now, okay. Practice it in the home, okay. Okay, So today I'm going to talk about the briefly explanation of the first hop redundancy protocol. Okay. So after that, next week we are going to configure the HSRP, VRRP, and GLPP protocols. So we are going to depth of this protocol. So first, I show you the FHRP. Okay, the main protocol. So what is the mean by FHRP is first hop redundancy protocol. Okay. So why we are using this protocol? Okay, to make the devices for unique features like redundancy, okay, the failover, the high availability, HA for the firewalls, clustering, RAID for the storage devices, okay, fault tolerant, stack wise, VS is also a stack, okay. So like this configuration, we are using the first hop redundancy protocol, okay. Is it clear? So if you have a good network design, if you need to provide a redundancy in devices and network links, okay, that's why we are using FHRP, okay. So redundancy is basically the extra hardware or software that can be used as a backup, okay. So the first unique thing is the FHRP we are using for the redundancy, okay. Wait, give me a second. Yeah. The redundancy, okay. And next the failover, okay, failover configuration, and the high availability, HA, okay, and clustering, okay, and next the RAID, okay, and next the fault tolerance, stack wise, okay, VSS. And the second point is, okay, it's need to be a good network design, okay. When you are designing a network, it's need to be a redundancy with the links and with the devices, okay. So if the main hardware or software fails or a link or unavailable, okay, in case of emergency, you need a backup, okay. That's why we are performing FHRP, okay. So it is a method that we are ensure network availability in case of network device or path failure, okay. That's why we need a redundant link and the redundant devices, okay. Also, it is a method for ensuring the network availability in case of network unavailability, okay. So the network redundancy is a process through the which additional or alternate instances, that mean the devices or components of the network, okay. Also the redundancy can be achieved via the failover, load balancing, and high availability in automatic way, okay. So if you have a devices, you can use the high availability, okay, within the devices, okay. So if you have a links, you can use the multiple redundant links, okay. So high availability is a feature which provides a redundancy and fault tolerance automatically, okay, because we are not going to configure or anything, we are not performing anything with the manual way, okay, because once we configure the FHRP protocols, okay, it will works automatically, okay. So the high availability is a number of connected devices processing and providing a services, okay. So the goal is here is to ensure that this service is always available even the event of failure or down, okay. So if there's something happened to network devices, okay, now its thing is failing, okay, so you need to work on a day-to-day workload, right? So we need the replacement, so that replacement which is called a backup, okay. That's what we are using this technology, okay. Okay, and next do you know what's the meaning of the clustering? Do you know what is mean by clustering? Hello, can you hear me? Anyone? Do
Yes.
you know? Yeah, do you know what is mean by cluster? In the data,
Multi,
yeah,
multiple switches.
the multiple switches. Yeah, in case of
Uh,
emergency. Yeah.
yes, multiple switches works as a single unit.
Yeah, the cluster means the multiple devices work as one. Okay, that's what mean by cluster. Okay, but actually in the network, okay, the cluster is similar to redundant servers. Okay, and provide the fault tolerance. Okay, what the mean by fault tolerance? In case of emergency, the device have a capability to work the day-to-day workload. Okay, so if there is a failure, okay, the device need to be a work. Okay, so a group of servers are logically combined into a cluster and seen as one device to work. Okay, so it can be configured as for the switches and also it can configure as for the servers. Okay, so think if device fails within a cluster service, so continue because other services continue services, because think if we cluster three switches, so if the middle switch is not working but other two are working properly. Why? Because in the cluster, if the one device is failing, it's not a matter. Okay. Also, it's same as for the redundant links. Okay. If some links are failed, okay, the link is forwarding the entire traffic. Okay. So this is what is mean to be FHRP.
Sir, excuse me.
Yes.
In the case of a failure in one switch,
Okay.
like, do you mean a hardware failure or is it a something
We
that
can do the
does
backup.
affect the?
Yeah, the redundancy means we can use as a backup, or the protocol wise, the link wise, we can configure.
So it means that even though one switch fails, like in hardware concept also,
Yeah,
if the backups are available with the other switches in the
yeah,
cluster,
yeah,
the system will work, right?
yeah. The system will work. Yeah. Okay. So there's a lot of theoretical part behind the FHRP. Okay. I'll explain one by one. Okay. So when you have a device, okay, so think if it is a router, okay, so think you have a connection to the LAN, okay, so think this connection is goes down and the old traffic would be fail over to the other internet connection. That means you need a backup. Okay, so think this is same as for your organization devices as for the ISP devices. Okay, so think your ISP is down, what happened, the entire network is going to be down. Okay, so you need a backup ISP also. Okay, so that's the one point, and it will eliminate the single point of failure and would reassure the availability and reliability. Okay, so think something happened to the this link. Okay, you need a redundant link pathways, right? So that's why we are using redundant links. And also, do you know the RAID? What is the mean by RAID? The RAID, the third point. What does it mean by RAID? RAID technology is mainly using data centers and also the server room. Anyone have an idea? What does it mean by RAID? Okay, for the RAID, okay, so which we are using hard devices, hard drives, okay, the storage devices, okay, which you are implemented on the servers or storage devices, okay. So which we need to be, so think in this storage rack, okay, we have a 1 2 3 4 5, okay, 5 hard drives, okay. Now it's work as one, okay. So think if something happened to the second storage, but still the 1 3 4 5 is still working, right? So now the users can access this specific storage drive because the others is still working, okay. It's not matter if the one is missing, okay. And the next thing is, when a device fails, another device takes over this process, which is referred to as a failover, okay. So that means I'll draw it and show you, okay. So think in your organization you have a main core router, also you have a backup, okay, which is connected to two ISPs, two different ISPs, okay, which means this one is working as ISP1 and this one is ISP2, okay. That means first one is using SLT or the second one is using dialog, okay. So in here in the LAN side, okay, to load balance, okay, you have a few separate switches or the stuff, okay. Now it's connected to switch boxes. Also, in case of emergency, if this link is down, okay, we need a redundant link. It need to be connected to the backup. Also, in the ISP2 side, this one, okay, the backup is also connected to the main, okay. So in case of emergency, okay, if this link is down, all the network which is coming from the LAN side will forward to this link, okay. And this link will forward the traffic to this the backup router, and it will send to the ISP. Now the users still can stay active, okay. But the thing is, when you configure the FHRP, okay, protocols, okay, you need to mention that if this link is failed, okay, if this link is failed, this is what happened, okay. If not, it's not working, okay. So you have to mention the interfaces, okay. If this interface fail, and the network traffic will automatically forward to this link, this interface, okay. So these things we are configuring, and I'll show you how to do that, okay, because we are configuring full protocols, HSRP, okay. HSRP is only for the Cisco devices, VRRP is the open standard, and the GLBP, okay, BP, okay. So the GLBP, okay, the GLB protocol is these two, okay, these two is for the Cisco, okay, and the VRRP is the open standard, okay. But when come to the load balancing, this protocol is best, but overall the VRRP speed is very fast. The conversion rate, the speed is very fast, okay. If there is a link state is going to be down, okay, and other backup is start with the 1 second, okay, because we are talking about the seconds and timers values, we are changing timer values, okay, we are changing the versions, okay. But the HSRP is still a slow protocol, okay. So inside this HSRP there are some modes, okay, which you can know. So within the configuration, I'll show you how to know about these protocols, okay. First we are going to configure these protocols, and next I'll show you the theoretical way, okay. Okay, so is it clear? Do you have any doubts regarding the FHRP? If you have any doubts, you can ask me. You have doubts regarding this? No?
No, sir.
Okay. So next week we are going to configure the HSRP, VRRP and GLPP. So both three protocols we have to configure. After that we are moving to the routing. Okay. Because we need in the routing we need more than 4 weeks to talk about the BGP, because the BGP is the main component of the CCNP routing. Okay, so other protocols we can finish up within 2 weeks. Okay, but the BGP is very different. Okay, so okay guys, so that is for today. Okay, so next week we are going to configure the FHRP. So I give you the brief explanation, but next week I'll deeply explaining the protocols one by one, HSRP, VRRP and GLBP with the configuration. Okay. Okay, so then see you next week. Okay. Okay guys, good night.
Okay, thank you very much, sir. Good night.
Okay.